I'm working on replacing those aileron cables now. I was able to get in there through the floorboards and get the connector off, the bolt out of that connector link underneath there on the torque tube. And so I cut the end off out here, the turnbuckle end off out here, and used a little bit of heat shrink tubing and spliced a new cable with the old one and pulled it through, and I got it to come all the way through and down in below the floorboards there. And I cut it off, so I've got plenty of length on that. Then I took the one that I got out of there, the one that was on that lower cable, I was able to run it through this carry-through cable. Yeah, I was afraid there for a little while I wasn't going to have enough cable there, but once I got it through I had plenty. It's going to be just right. I'll have a little bit to cut off. Well, I've got that one hooked back up. Getting those aileron cables set up again. I've got them all done now except for this one. This is the bottom one on the right wing. Got my control stick in, and I got it tied up, centered, and then I took the link there for the carry-through cable, centered it, and clamped it onto the carry-through spar. The last time I did them, I was so conscientious about getting them too loose that I wound up getting them too tight, and I'd set them up exactly the same way, except I only put the turnbuckles in about halfway. And when I started turning them down to tighten it up, they were way too tight and I couldn't get them in. So this time I put the turnbuckles in, so they're the threads are just inside the turnbuckle, or just on the outside edge of it, and then I pulled them tight, clamped them up, squeezed them off like that. So this is what I'm doing. I'm using a set of the sizers or forceps, and I pull that cable through the NicoPress sleeve around the eye and then back through the NicoPress sleeve, pull it as tight as I can, and then clamp it with these sizers, forceps, and then I'll take my NicoPress compressor and compress that sleeve. I've taken my ailerons and I put a little piece of foam on them so it doesn't distort the fabric and everything too bad. And I've got a big spring clamp out there that I clamp the ailerons flush with the wingtip, and that gives me the right attitude for the wings, the right position for the ailerons. Now, in here, I've got a control lock that slides on between the aileron and the flaps, and that holds the flap and the aileron in relative position. Most Cessnas have a control lock that's a pin that fits down in the control column there behind the wheel. Well, my Cessna 170 never had that. It didn't have any control locks like that. But I never really did like the control locks like that anyway. My opinion of that was the control locks, when you have wind and stuff that are moving your controls around or putting force on them, and you have a control lock in there on the controls itself or in the cabin itself, all that force is transmitted through the whole system and into that pin. So it does a little bit of good, but I think that all those forces and stops and everything get transferred in there. I like external control locks a lot better because they prevent the surfaces from moving completely and stop them at the source rather than transferring all that load all the way through your control system. And because these Pipers, these Supercubs, the flaps aren't locked up. Like a Cessna, when you put the flaps all the way up, they're locked there. On the Piper and at the Araucas, Citabrias and stuff too, the flaps are held up with a spring. So when you get wind blowing over them, it flops those flaps up and down. There's nothing to lock them up except that spring tension. So a lot of guys will take their flaps and pull them so that they're all the way engaged, all the way down. Then they're locked like that. But to me, you're putting them all the way down, and that's allowing the full force of the wind against the flap when it's coming from either behind or in front, putting a lot more force on it. But the other thing that happens, I noticed that on this plane, was the flaps were down, that water collected inside the trailing edge of the flap and then stays there. And then when I would do that, I put the flaps back up, water just running out of those drain holes in the flaps. So I always just kept them up. I'd rather keep them up. And so I like this idea of locking these in with the ailerons here with these control locks better than locking the flaps down by putting the flaps all the way down and latched. This control lock slips over its shape in the airfoil shape of the aileron and the flap, and it's split in the middle there. It's bent aluminum, or two pieces of bent aluminum in that airfoil shape, and it's got a little foam in there for cushion, and it slides over and right between the two controls, and then there's a bungee that goes around the jury strut and holds it on there, and that's an F. Atlee Dodge control stop there, and I like that one better than most of the ones I've seen. Only problem with those is with the ones that are in the control in the cabin, you've got to take them out before you can fly the airplane, and these are outside the airplane, and if a person's not real conscientious on your pre-flight inspection, you might forget those on there, and that could cause havoc. Now, the other place I need one on here, that I'd like to have one on here, is on the rudder, but the rudder hangs out over the water when we're up on the ramp, and it's really hard to get to, so I haven't really figured out a good way of putting a control lock on the rudder. Okay, I got the ailerons all set up. I think they're pretty good. I got the cable tension here pretty good. I don't have a tensionometer to check and see what the tension is on them, but the old way of checking them was, in the book, was not too tight and not too loose, and these are, I can bend them a little bit here so they're not too tight, but they're a whole lot tighter than they were on the other airframe when I had the other airframe on. So that's pretty good. I think that's just about right. I don't want them too tight with these pulleys that don't have bearings in them. I got those all hooked up and the turnbuckles tightened up, and then I put the keepers in the turnbuckles. Now these turnbuckles have little slots in the screws on them and in the turnbuckle portion of them, and they take these little spring clips that fit in there, and you've got a wire end that slides down in the groove in the turnbuckle, between the turnbuckle and the screw. There's a groove in each one of them, and that fits down in there, and then this little spot here fits down in the little hole in the turnbuckle end and clips down in there. So there's two of them on each turnbuckle, one on each fork. So those are tightened down, and those are safetied. That's the, in lieu of safety wire there, that's what you do with those. So those are done. Well, I've got one more thing to do that is pretty important, and I want to check and make sure the controls travel correctly. When I push the aileron control to the left, when I push the stick to the left, the right aileron should come down, which gives more lift to the right wing and causes it to come up, and that initiates a left-hand bank. And then the opposite, when I go to the right aileron should go up, decreasing the wing on the lift on this wing, and the left aileron should go down, increasing the lift on that wing, which would initiate a bank to the right. And so those are correct, and they're moving freely. There's nothing stopping them. I don't hear any drag in there. Well, let's check on, make sure the left one is traveling. Okay, left wing is, aileron is to the right for a right bank, right turn, and the left aileron is down. And now we're to the left bank, and the left aileron is up. So that's good, free and correct, nothing interfering with that. Okay, now we'll look back here on the tail, do the same thing with the elevators. And on the elevators, when I pull the stick back, that's what we want to do when we want to raise the nose up. The elevators should come up, which would decrease the lift on the tail, or force the tail down, which would push the nose up. And they do go up. And when we push forward on the stick, they should go down, and they do go down. That adds lift to the tail, which picks the tail up and pushes the nose down. Those are good. And you can't see it hardly behind the curtain, but I push on the right rudder, and it turns to the right, and that's what it's supposed to do. And to the left rudder, and it goes to the left. Okay, that's right. That's correct. Those are all correct. Now I want to check the trim, and nose down trim. Okay, that raises the horizontal stabilizer, which increases the lift on the tail, which causes the tail to go up and the nose to go down. And we got nose up, and that does exactly the opposite. That makes the horizontal stabilizer go down, decreases the lift on the tail, and raises the nose up. So all of that works good. About 36 years ago, I was managing the airport in Sandpoint, Idaho, and one of the customers that I had there, his name was Bill Piper. Bill Piper inherited a Comanche, a twin Comanche, from his father. When his father passed away, his father was Bill Piper, I think it's Pug Piper. He was one of the owners, the grandson of the founder of Piper Aircraft Company, and was either the CEO or one of the owners. Anyway, he and 4 other people were killed in an airplane accident on takeoff from the Piper factory. They were test flying an airplane and the controls were rigged incorrectly. And when they took off, they went to turn or climb or something, and the airplane did exactly the opposite and crashed and killed 4 of them, 4 of the top people at Piper Aircraft at the time. So that was a hard lesson to learn, even if the pros, the professionals, the people who have been in the business all their life, those were, of course, the owner, one of the owners of Piper, and the chief engineers, and I don't remember who all the titles were, but they were the hot shots in the company there, experienced pilots and experienced mechanics, and they flew an airplane that was rigged incorrectly and got killed because of it. So that's a hard lesson to check the control travel and make sure it's correct. And we have correct control travel on this airplane, so that's a good thing.